sciences?
Yes, good.
Okay, excellent, thank you. All right, so as I was saying, this is a session that was organized between CI Compass and some of our facilities and the ESIP folks at the ESIP winter meeting session. I'm going to go fairly quickly through this since it was an hour-and-a-half session, but it was recorded. And so we've got lots of good discussion, presentations from a couple of different communities, including the Wikipedia, Wikidata editors themselves. So this sort of provided some really good feedback on how other communities, the Smithsonian, other sorts of library systems are using it. Okay, so what is Wikidata? Just to make sure that we're all on the same page, it is actually a knowledge base. It's structured as a knowledge graph using structured data, and it provides essentially the structured information to Wikipedia and a bunch of the other Wikimedia projects. And it's based on free license, open standards, and basically open data. And it shares some common architectures with Wikipedia in terms of the sort of traditional sort of relational databases, but it has a linked data, knowledge graph sort of layer on top that lets you actually explore it as linked data, and linked data using persistent identifiers, web standards such as Sparkle to be able to do graph-based queries of it. And so it becomes pretty useful in order to connect data together. And so the thing that sort of I was interested in is this motivating article from the life sciences, right? That Wikidata is a knowledge graph for the life sciences. And as it turns out, Wikidata has, the life science community, they sort of pioneered the FAIR paper. It came out of that community. A bunch of the same people that are part of the FAIR paper are also part of, creating Wikidata as sort of this FAIR knowledge graph, right? And so I'm sort of wondering out loud of not just for the science, for the earth sciences, but maybe it's a knowledge graph for the sciences, right? And I'll present a couple of just quick examples of what that is. Back to my favorite topic of AI, I was at this NLP summit last fall, which is a sort of commercial summit, only really companies presenting. And there were many presentations where Wikidata is being used in terms of commercial machine learning, especially for drug companies. So this was Roche, the pharmaceutical company, essentially using Wikidata as a way of doing machine learning, right? One of the nice things about Wikidata is that it has these collaborative editing tools that lower the barrier to using them for structured data. And they actually provide recommendations on what sorts of relationships might be useful to annotate your node in the knowledge graph with, right? And so that becomes pretty useful for novice users, right? Provides queries, right? And so these integrated queries stretch across different databases because there's cross-database identifiers. That's pretty useful. And they allow for reuse because I said this was open source sort of approach. That one good example is WikiPathways, which is trying to curate biological pathways. They reuse a lot of the same infrastructure that was developed by the Wikidata tooling folks, right? And so this also lowers the barrier that you're not trying to start, developing things from scratch. And as I mentioned earlier, the external identifiers, right? And so because there are these external property identifiers, you can do crosswalks between, say, the environmental ontology and WikiPathways, right? Or other sorts of external databases, right? That may be shared as linked data. And this becomes pretty interesting in terms of being able to connect publications to data sets that were created in that publication. So there was this recent example of this paper, this mRNA paper that is archived in Wikidata, the paper identifier, but because it's stored as a graph, right, which is the thing on the right-hand side there, you get to see the context behind the paper and links to all of the other information that was used in it, plus the topics, right, that are associated with the paper for doing NLP and other sorts of machine learning, right? And then there are these sort of crosswalks, right? And so this external identifier in the paper in Wikidata points to something that's in Scala, which then points to something that is in WikiPathways, right? And so you can go from the sort of paper to the topic, the non-alcoholic fatty liver disease as an instance of a biological pathway to the actual pathway itself, right? Which is kind of a nice way of connecting information, which is on completely different systems, right? And back to a publication, right? And so this is a way that communities are building on that. The other example that we gave is the drone data community, which this is an example from a collaboration that I have with a alumnus of CI Compass, Jane Weiger at South Africa. And so there's a project that is essentially taking using linked data and fair data principles for drone data. How can we basically improve science that's being done on drones? And using essentially Wikidata as a hub for storing this information. And so we create identifiers for the designs. So if somebody builds this open hardware, somebody builds the drone, they can basically point to the design, all the design information that is stored in Wikidata. Plus, it's an identifier for when they collect data sets as to what the configuration of the sensors and everything else was, right? And so those then are expanded out in the fact that there's a Lander's drone. There's a particular version of it that's for a hexacopter drone. And then it uses a standardized open source autopilot called Orange Cube. And so we can link to the component parts so people know what is being used. We can even link to the sensors, right? And so in terms of a particular set of barometric pressure sensors, what the units of those are. So it uses QDIT to basically say what atmospheric pressure is being measured in, right? And so it gives you a way of essentially querying this information through the Sparkle API. It also gets you a way of standardized validation through these shape expressions, right? And so that, I think it sort of may have frozen. Okay, so it's not advancing, but this was essentially the last slide of the set. So in any case, what the idea was that we wanted to start this discussion, and hopefully there'll be some comments and thoughts. I'm also having office hours after this, so if there's any questions on any of these topics that I brought up, please feel free to drop in at my office hours, and we can have a sort of an informal discussion and talk.